Hi, my name is Artem. In this video, I will tell you what logarithmic and exponential functions are and how they can be used in real life to visualize data and statistics. Logarithmic and exponential functions are very much similar to each other. Exponentials essentially show data that's consistently multiplying itself, as in the y-axis increasing more and more per every x-axis interval. Logarithms are just another more condensed, more zoomed in way, I guess you could say, of visualizing exponential functions. In log functions, the y values are divided by a specific number, usually starting from 10, and the next number increasing by a multiple of 10. So it would start from 10 and then go up to 100 and then 1000 and so on. Therefore, a function where the y value is any amount greater than the previous one in a logarithmic scale represents an exponential growth. A great example of where these two functions can be used in real life would be with the ongoing pandemic. Let's take a look at the examples of each graph. So starting with the exponential graph. This graph shows the total number of coronavirus cases over time up to May 21st. The y-axis represents the total number of cases and the x-axis represents time by intervals of 5 days. The graph itself isn't an exponential function, but rather a certain time frame in it. As you can see, the graph looks like an obtuse angle of a triangle. From January 22nd to March 22nd, and also from April 1st to May 21st, the graph looks linear. The exponential function, however, lies between January 21st and April 1st, where every 5 days the increase in the number of cases for a day was more than the total number of cases in the previous 5 days. Now here's a logarithmic graph. This graph shows the total number of cases over time up to May 21st and has the same axes as the previous one. Here, the graph looks like a wave though. As I said above, any increase in the y value over time means that the actual graph looks exponential. So, with this logic, we can tell that the greatest change in growth happened in the early stages of this pandemic, as one might expect. So that means from January 22nd to early February. After that, the function still increases, so technically the cases are still exponentially growing, even right now actually. This is just one of the examples where these functions can be used in real life. More examples include finances, population growth, radioactive decay, and compound interest, which we've also learned this year. Thank you so much for your efforts this year, Ms. Parker, especially during the tough last marking period of the year. I really appreciate it. This has been a wonderful year. Thank you for watching my video. I am Artem Bagadikov from Fairfield Ludlow High School.